Stone renovation projects. It's two things. It's connecting object data, which is a bit richer than linked data. We'll come to that later. And it's natural stone renovation project, so it's heritage buildings. And this is one of the subdomains of the construction industry that has a lot of issues with digitizing. However, it's super relevant that we digitize here because this guy on the platform needs a lot of information to make decisions on what should happen with this stone block there, such as its location, the historic value of the thing, the status of the block, the shape, the material, whether it has damages, etc., etc. And to give some sense of size, we have 60,000 national heritage buildings in only the Netherlands, and these buildings have thousands of these blocks, and for each block we need all this information. And generating this information is, maybe this is one of the first circular industries in the built environment, because this goes on and on and on, because we renovate the building and then it stands there for 20 years and then we need to renovate again, and we need, well, it would be nice if we had that information from previous times. So there's a lot of people involved in generating information and using information in different time steps of the process, and they follow a hell lot of schemas and structures and guidelines, etc. And this differs for different buildings and for different locations and so on. And the result of this is that for each blocks we basically do this, we generate a lot of information that is totally unstructured. There is no database or so that connects all of these things, and we now basically rely on typically, at best, spreadsheets, but typically it's whiteboard information or paper based still. So we have an integrated data silos, we're total dependency on 2D drawings and underutilization of 3D drawings. And the idea here is, can we connect all this information into one graph and use it? So what we did is, the basic principle, can we extract what is in these spreadsheets, can we convert that to a graph, can we link that to graphs of other spreadsheets, and then can we link the original files that were created in the graph somehow. So we don't aim to translate everything to RDF. We keep most of the files that exist because they exist, but we simply connect them with the graph. And this is what we mean with connected data instead of linked data. And then, so that's part one. Then part two is, can we put that information in this iPad of the guy on the platform so that he doesn't have to go to the construction hut on the ground floor every time he needs to make a decision, 20 minutes up and down. So to understand what's happening, we went to the National Monument in Amsterdam. They're renovating the thing, and we spoke to a lot of these people. So to understand, what decisions do you make, what information do you need for those decisions, what information do you generate, how does it look, etc. And the result of this is basically three things. First, the process analysis, so BPMN schema of all the decisions this guy on the platform makes, and all the information that is generated in those decisions and that is needed in the next step. Then based on that, a set of 7 simple competency questions. So what information would you like to get out of such a integrated graph or system? And based on that, a use case diagram. So if we would design a system, what buttons would you like to click on, etc. And this resulted in a design of a system architecture. So what we did, we had these silos of information. So we had IFC data, we had photos, we had spreadsheets with inspection data, etc., etc., etc. And we reused and created ontologies. Then we had an ETL pipeline to convert some of the data to graphs using IFC to LBD converter and some custom Python scripts. So this is the graphs. Then we also had a web-based document storage where we stored the original files, and we then created links between the graphs and the original files. We had a layer of services, so we were able to query data and do inferencing on the data so we could reason. And based on the queried metadata from the graphs, we were then able to automatically query the right documents from the document store. This was all implemented in a user interface, which is called LBDviz, or Heritage LBDviz, which is based on IFC.js and Communica. And we also built an Excel exporter because these people like Excel sheets. And now they manually fill in Excel sheets all the time, while we could actually export everything in one Excel sheet, so it was very convenient for them. Then we created different functionalities based on the different users that were using the system, and we built a kind of a pipeline back using, like, integrating with all their Autodesk systems so that they could also, like, make changes to the IFCs, etc., and then automatically put those changes in the graph again. To structure information, we relied on ontologies. We reused most of the ontologies. So assume there's this building with one object. We call this thing both element, and elements can replace elements. Elements have a geometry and all kinds of other properties. So we created specifications of geometry such as width, length, thickness, and it also had shape, material, a physical tag, and a location. Those were element properties, and those element properties are captured doing tasks. So we reused the CTO ontology for this, and properties can have values and time. Then elements are subject to tasks, two specifically, inspection tasks and repair tasks, and they can have damages. And these damages are captured during the inspection task, and we try to repair the damage in the repair task. And these actions are called interventions. And there's a large subtree of interventions that we created based on all these guidelines that exist. So they have to do interventions that are either preservation or repair or reconstruction, etc. That's how they name these things. Yeah. And then finally, during tasks, we can capture resources. They can be anything, but one of the subclasses of this is external images. So we can then via a file path link the external image to the task, and via the task to the bot element. So these ontologies and the system architecture was then kind of created into a software architecture. This is Heritage LBDviz, and it can do a few things. It's a model viewer, so this is all web-based tool, so no installation. So what you can do is you can look at the model, you can click on things, you can make 3D sections. This is all based on IFC. So this was just handy for people to explore what the building looks like. But we can also, for example, measure things, etc., etc. Then we could query data via Sparkle queries. So there is a Sparkle box, and you can run your query, and then you should get results. However, the guy on the platform that needs to deal with these stone blocks is probably not able to write Sparkle queries. So what we could also do is hide Sparkle queries behind buttons, basically. So you can click on an element, and then you can click on one of these buttons. Then in the back end, it executes a Sparkle query, and then you can get information. In this case, for example, properties such as the width and the height of the block, etc. So now we know that this is a stone block from Tuscany with a certain size, etc. Then we could also get the objects from the web-based storage. So for example, images. So we could click on photos of the block. Then it would first run a Sparkle query to find the file path of the photo, and then in the second database it would get the photos. So you would see all the photos that were made over time of a block. And we could also infer and reason on top of the graph, because we have these tasks with the timestamp. We kind of inferred that if, for example, a stone block was transported to a renovation company, and then a task was completed, and it was transported back, and it was put on the building again, that this thing was finished, right? So based on these sequences, we could highlight which of the blocks in the building were already finished and which still needed work. Those are the yellow ones. And then in white, we have blocks where we could not get any information. So then at least we know that information is not available. And finally, we could, based on the results that we get from the queries, we could click on them and then automatically highlight which block this refers to. So yeah, if you query for a specific block which is not finished, then you could find which block this is relatively easily. Then finally, we were able to generate those spreadsheets. So this is what they normally fill in manually. But we could simply query it and structure it and automatically fill this. The nice thing is that because we have the locations of the photos, we can hyperlink them and click on them, and we could also open the exact the exact block that we have in this Excel sheet in the model. So we click on the Excel sheet, and then we get to see the block in the 3D viewer. So the people can still use their spreadsheets, but now they can click on the thing to explore more, and they can then, based on that location of that block, find more information and put extra queries, etc. So yeah, we don't replace what they do, we just enhance it. So to conclude, should we connect object data and natural stone renovation processes? I think yes. What we did, we closely followed existing processes so that we were able to answer real competency questions, so to actually help the people that are there and to give them answers to their actual questions. And this saves a lot of time and money. And we hardly validated this because it's very difficult, because these projects are not so repetitive. But yeah, just anecdotally, the fact that normally a worker needs to go down to the construction hut to look at drawings and to find the photo in the Windows system or so, or Autodesk system, takes a lot of time, and now you can simply click on the object and find everything that is there. However, this was very much focused on a Dutch context. I can imagine that other countries have different procedures or different guidelines and might need differences in the ontology. We very much focused on one case project and the experts on this case project, so maybe other experts would have other competency questions. And we had some difficulties with reasoning, so the Communica thing did not perform too well with like reasoning in the front end, so we need to kind of fix this. Okay, that's it. If you want to play with the tool, it's there. If you want to rebuild the tool, there's the tutorial, it's there. The ontology is there, and all the case study data is there. So, and please use it, please build on top of it. It's open source. Thank you.